All right, we've looked at a couple different situations when it comes to writing equations of lines. We've seen how to do that when we know the slope and the y-intercept. We've written equations when we've been given the slope and just a point that our line happens to pass through. The last situation that we're going to encounter is how do we write the equation when we're not given the slope at all? We're just given two ordered pairs. As you've seen, anytime we're going to write the equation of a line, we need to know what the slope is. So if we're not given the slope, we're going to need to use our ordered pairs in order to find the slope of our line. So let's do that to start with. Let's look at our y values. If I go from -6 to 6, my y value is increased by 12. So my change in y would be 12. And now let's look at my x values. My x values went from -2 to 4. That would be an increase of 6. And if I simplify that, 12 over 6 is going to simplify to 2. So we've just determined that the slope of our line is 2. Now I really just need an ordered pair that my line passes through. We've already done problems like that, right? When we know the slope and we know an ordered pair, we can write the equation. And I actually have two ordered pairs. So I can pick from either one of them. So I'm going to use 4, 6 just because it has fewer negatives in it. And because I don't know the y-intercept, I'm going to start with the point slope form of an equation. So if you remember, that looks like this. Y minus y1 is equal to slope times x minus x1. And now I just need to substitute the appropriate values in the correct spot. So I know slope, I know what I'm going to put in for m. I've got an ordered pair, I'm going to use 4, 6. So I can put 4 in for x sub 1 and 6 in for y sub 1. So let's substitute our values. I'm going to get y minus 6 is equal to 2 times x minus 4. Now, depending on what we want the final form of our equation to look like, we could possibly be done at this step here, but we oftentimes like to have our equations written in a little bit neater form. And usually slope-intercept form or standard form are a little bit easier to work with. So I want to rewrite mine so that it's in slope-intercept form, which means I need to solve for y. I want the y sitting by itself. So I need to get rid of my parentheses. So I'll use distributive property. 2 times x would be 2x. 2 times -4 would be -8. And then I need to get rid of the -6 by adding 6 to both sides. So that would give me y is equal to 2x. -8 plus 6 would give me -2. I've just written the equation of my line that passes through the points -2, -6, and 4, 6. And if we wanted kind of a check of that, we could go ahead and plot those two ordered pairs, and let's graph that. So I had an ordered pair at -2, -6. I had another ordered pair at 4, 6. And if I draw my line through those 2 points, I get a graph that looks something like that. I'll draw my arrows to indicate that this is going to keep going forever in both directions. And let's see if that fits in with my equation. So my equation tells me I should have a slope of 2. And if I look at my graph, it looks like every time I move up 2 squares, I'm moving right 1 square. So that fits in with the slope of 2. And if I look at my y-intercept, it looks like it's hitting right there at -2. So that confirms what we ended up with. There's my equation. Y is equal to 2x